Alright, how's it going everyone? I'm Eric, good to meet you. I'm one of the instructors for CS 1501 and this week I'll be giving you an introduction to Git and GitHub. So what is on our agenda for today? First I'll go over the Git in GitHub, then I'll go over what GitHub actually is, then some terminology, along with that the interface of GitHub. After that I'll go over some common interactions that you can do with Git and GitHub. Then I'll go over the difference between remote versus local repositories. Following that, I'll go over a typical workflow that you use with Git and GitHub. And then some bit more of an advanced topic that I'll touch on throughout the slides, and that is Git branching. Then I'll mention some pretty great resources for you to use to practice everything that you learned in this video. So, what exactly is Git? Git, as it says, is an open source distributed version control system. So what does that mean? Well, open source, that just means that the code is online, it's available for you to see, for you to look at, for you to even edit if you want. Now, if you actually want to edit the official Git, then you have to go through this whole revision process, of course, but it's there if you want to. Now, distributed, that essentially means that it's connected. It's connected in some sort of way that we'll touch on in the later slides, but a great example of a distributed system would be just the internet. The internet is just a connection of computers that can all talk to each other. Git is pretty similar in that facet. Now we get to the sort of crux of what Git is, and it's a version control system. What the heck does that mean? Well, the next sentence kind of gives you some clues. It tracks changes to code and stores different versions and modifications in a central repository. So that's a mouthful. What's going on there? Well, by version, what do you mean by version? We mean the different versions of your program. So as you develop your program, you're going to have different changes that you want to be added, features, maybe bugs that you need to fix. All those can be summed up in different versions. Now, you can imagine how frustrating it would be to keep track of all those versions. So maybe go back a couple versions, go back a couple features to what your program was before. Perhaps some bug was introduced in those features. How difficult would it be if you didn't have some sort of system like Git tracking all your changes and essentially allowing you to go back to different versions at the click of a button? So that's what Git allows you to do. It tracks your different versions of your program as it changes throughout, as you're developing it, as you're changing it, and allows you to go back essentially whenever you want, erase certain changes, bring back certain changes. Essentially, it's a great tool for developers to collaborate, download new versions of code, make changes to the code, and upload the newest revisions. So then what is GitHub? Well, as the name suggests, it's the hub for Git. It's a hosting platform for your code, essentially your Git repositories, that is used to manage Git. Now, it allows hosting of open source projects, private projects, public repositories, which are essentially just open source projects, and lets developers work together remotely. Now, it contains tiers, free, team, and enterprise. Don't worry, you won't have to pay a cent, however, because the team and enterprise tiers are, as their name suggests, mainly for teams and companies that want that extra support from GitHub. If you're a student, it's even better. You can get the student developer pack for free. GitHub is always looking to benefit students, to give them free resources like tutorials, websites, free trials for different pieces of software that could help you write code better. So next, let's go into some of the terminology that I may have mentioned without really properly explaining them. I know I mentioned repository a couple times. You might have wondered what the heck I was saying. It's also called repo for short. Essentially the location, I guess folder, you could say, where all the files and all the other folders for your project are in. And it's also the sort of the central component that Git tracks. So what is forking a repo? Essentially taking a project that already exists on GitHub or a service like GitHub, like GitLab or Bitbucket, and essentially creating a new project based on that. So it's copying all those contents, making the new project under your name, right? So it's no longer on the other developer's name, it's under your name, so that you can make changes without affecting the original, without having to go through any revision processes for that original project, whether they may exist or not. Now, a pull request often happens after you've forked the repo to make your own edits, but then you decide, hey, I would actually love this feature that I made to program A to actually be in the official program A. So it's a process that you go through to submit your contributions to other projects. Now, branch. We'll get into this later on the slides, but a branch is essentially a divergence from the main line of development. So if this is the main line of development, let's say this is your program, it's all nice and healthy, no bugs, but you decide, hey, I want to add this new feature, let's call it feature X. Now, you have some concerns. Feature X might introduce some bugs. You don't want it messing up this main line of development. So what you would do in Git is you would make a new branch. This is essentially saying, hey, I'm going to kind of go off in this other direction from the same starting point as the main branch is at right now, just sort of veering off to another direction, developing that new feature so that any changes you make on this new branch don't affect the original. So that anyone downloading your program from your main line of development, also called the master branch, won't get the buggy feature that you're working on this other branch. Now let's go through some of the interface of GitHub. You can see the first thing that sort of is in bold there in the top left corner is the username of the owner of the project. This could also be an organization name. And then you have the project. So this is Andrew's project, who gives CS4260, most likely some project for his class. You can see also there's a private symbol there, just indicating that this is a private repo, which means that no one is able to find this project on GitHub or contribute to it unless Andrew himself gives them permission to do so. Then you have sort of the main content box. You can see, just like your file browser on your Mac or Windows computer, there's folders and there's files, right? You can see next to the folder and file names, you have these, you can call them messages. These are what are called commit messages, which we'll get to in the later slides, but they essentially describe the changes that were associated with these files. So you can see, for example, right next to Travis setup, Andrew has a commit message that says more Selenium and Travis. So probably implying that he added more things related to Selenium and Travis, whatever they may be. Then you have the branch sort of drop down. Right now it's set to master. That is a default for pretty much every project on GitHub, as it is the main line of development, as we talked about before. If you clicked on that drop down, you would see all the other branches that are available, that exist for this given repository. If you didn't have other branches, then you wouldn't see anything. Next, you have this nice flashy green button. It says code, a little download symbol. This does what you would expect it to do. If you click that drop down, you'll be given a list of options that will allow you to either download the project as a zip file or clone the repo, which we'll get into later, but it essentially is taking the Git repository and sort of downloading it to your local computer, but it's different from the zip file in that it also contains the Git information. It also contains all that tracking that's done by Git, so you can see all those commits and go back to previous versions if you want, or add a new branch, things like that. So now let's go over some interactions that you can do with Git. First one that comes to mind is, of course, init. Init, short for initialize, essentially creating a new local repository, a new repository on your machine, on your computer, desktop, or laptop. Clone, as I mentioned before, is downloading repository. It's downloading a repository from a remote location, yes, but it's also getting all the Git information from that repository as well, or within that repository as well. Add is what you do when you've sort of made the changes that you want in your files and you're sort of ready to, I guess, make a commitment to include them in a new version, but you're not that ready. Perhaps you still have some other files that you want to make changes to. This is what we call the staging, I guess, stage, where you've made the changes and you're sort of moving them to a new stage, essentially saying, hey, these changes I like, these changes are probably what's going to be in this new version, but I'm not exactly ready yet. Maybe I have still some more changes to add. Maybe I might want to modify them, right? So it's sort of this intermediary period. But this intermediary period is followed up by a git commit, where you say, hey, I love the changes. I'm pretty sure that these are going to be what's in the new version. And I'm going to make that commitment. I'm saying, yes, this is my change, and it's usually accompanied, it should almost always be accompanied with that commit message, with that description of what the changes are doing exactly. Then you have push, which is essentially taking the changes that you made, taking that new version of your local branch on your machine and pushing it, uploading it to that remote branch in GitHub or GitLab or Bitbucket, just some other services that offer the same sort of thing that GitHub does. Then you have Git status. This is just saying, hey, what is the status of my project, of my Git repo? What files have changed? Files didn't? What have I added? What have I staged? And then Git branch simply lists the branches of your project, similar to that drop-down arrow that you saw in the GitHub interface. Now I'll sort of go into the differences between the remote and local repository. So as you can see, developer A, he's taking that working copy, he's making his changes, he's staging them, putting them in the staging area. Then after he's sort of ready to make that commitment, he's making that commitment, he's committing those changes to his local repository, and it's still in that local repository. Then when he's finally ready, you see that big push arrow pushing his local repository into the remote repository in the cloud, in GitHub or Bitbucket or GitLab. And then you see some other red arrows. So you see the clone arrow, that's sort of indicating that it's taking from the remote, moving it to the local. See the fetch? So it's dotted, and that dotted line indicates that while it is taking something from the remote to the local, it's not exactly applying it all the way. In the sense that fetch essentially grabs the the meta information, the information about the new changes, whether or not there were new changes, and updates the local repository that way. So no actual files are changed when you run a fetch command in Git, but your Git repo now knows whether or not changes were made. It's simply an information tool. And this fetch is often followed up by a pull. A pull is essentially the complete thing. It's saying, hey, I want to take all the changes in the local repository and pull it, download it into my working copy. This is often done when you already have that repo set up. You can see it's very similar to the clone. What's the difference? The clone is when you don't have that local repository yet. When you know the GitHub repo that you want to take and make modifications to, but you don't have it on your machine. So you clone it. You download it to your machine with all the Git stuff. But the pull you do when you already have it, when you've already cloned it, whether it was yesterday, 2 weeks ago, and you want to get those new changes. Now you see on the developer B side, sort of just going through the same sort of commands there: clone, fetch, push, pull. Just showing that GitHub allows multiple developers to work on one remote repository. So here's sort of a typical Git workflow. First, you want to clone the central repo on GitHub or GitLab or Bitbucket. And this is, of course, only if you don't have that local copy yet. Now, after you have that local copy, you can make those changes on your machine, maybe add that new feature. Then, once you've done that, you will add those files to your staging stage within Git. And then after you've added all those files that you're happy with, that you're like, all right, this is my new version, you're going to make that commitment. You're going to commit those changes. You're going to repeat steps 2 and 3 until you're really happy with your changes and you're ready to share them with others. Then you want to push. Push, of course, is taking your local changes and uploading it to your remote repository. Now, before you push, some words of caution: you should look at and pull any changes that others have made first. And then a lot of times what's going to happen is there might be some conflicts. Someone who pushed a change before you might have edited the same file that you're editing. This is going to cause what's called a Git conflict. And that is something that Git can't help you with. Because what is Git supposed to do? Is it supposed to take the changes that your buddy pushed earlier, or take your new changes? That's something that's up to you and or other people on your team to decide. Now, don't worry, you won't have to deal with any of these Git conflicts in the activity for this week, but it's something to really keep in mind as you move forward in your developer journey. So then we'll go into Git branching, the sort of advanced topic that we have been mentioning throughout these slides. As mentioned before, it represents that independent line of development. So it's used as a way to generate a new sort of working directory, staging area, project history for either a new feature, some experimentation. Maybe you just want a clean workspace to work on, to do some whatever you want without affecting the main branch or any other branch for that. As you can see in the diagram, what's commonly shown as an example of branching is when you want to add that new feature. So you have in that little red rectangle, that common base, that's where it starts off from. And then you might kind of branch off into that new feature. Now your master branch is still chugging along, it's still getting the maybe there's some bug fixes or whatnot that are unrelated to the new feature that are being added. And then the new feature is sort of being worked on below. Once it's ready, it will be merged into the master branch and all will be good. So this, as I said before, is the process of combining the changes you made on one branch to another, usually the master branch. And of course, as also explained before, make sure to watch out for merge conflicts. Combining the differences in code between the two commits, there might be a time where one file is changed by both the master branch and this new feature branch. You're going to have to work out which changes you want from those two. So putting it all together, the common workflow for Git branching involves cloning the master repo onto your local machine, making that new branch for this new feature, doing the work on that branch, pushing the changes to that branch on to GitHub, right? So GitHub is going to have that copy of that new branch, and then you're going to want to switch to your master or production branch and then merge that new branch into your master branch. So again, a lot of stuff, but of course, the best way to master it is to practice. So while we didn't go over the actual process of using Git and GitHub in this video, sort of just a rough overview of the concepts involved in Git and GitHub, you can use these resources listed here to actually get hands-on with it, to actually practice the commands, practice the concepts. Don't have to do them all, but I strongly recommend you to try at least one of these exercises. So that's it for me. My name is Eric. Hope you enjoyed this video. Hope you learned a thing or two about Git, GitHub. I wish you luck on the activity, and I'll see you next week.